This is Algebra 2, Lesson 1-5, Solving Inequalities. A compound inequality is an inequality joined by the word and or the word or. So I could have like 2x plus 3 is greater than 7, or 2x plus 3 is less than -5. That would be a compound inequality. Words like at most and at least suggest a relationship in which two quantities may or may not be equal. They are inequalities. You can represent such a relationship with a mathematical equality. Just like you use the properties of equalities to solve equations, you can use the same properties of inequalities to solve inequalities. One of the things you need to do is remember how to write graph inequalities. Let's just refresh our memory. X is greater than 4 would be a greater than symbol. If it doesn't equal 4, that means you have to use an open circle. So when you graph x is greater than 4, you have an open circle at 4 with a line to the right. X is greater than or equal to 4 means 4 is part of the solution, which means you now close that circle and go to the right. Less than 4 means it's an open circle and goes to the left, because on another line, less than is to the left and greater than is to the right. Remember, if you write your inequalities in which the variable comes first and then you have your symbol, the symbol always points which direction you should graph. Okay? As long as your variable comes first, the direction in which you should draw your graph should be the same direction your inequality symbol is pointing. And then you just have to remember if it's an open circle, okay, it's greater than or less than. If it's a closed circle, that means it's greater than or equal to or less than or equal to. That's the two most important things. All right, let's write an inequality from a sentence. And as with all other things, you have to make sure you define your variables. Letter A, 5 fewer than the number is at least 12. You're like, well, wait, you told us about greater than or equal to, or greater than or less than, but you didn't talk to us about at most and at least. Well, just refresh your memory on this. If I said I have at least $5 in my pocket, that means I have $5. Or I can have more than $5, but I don't have less than $5. At least means greater than or equal to. Which means, if at least means greater than or equal to, at most means less than or equal to. So 5 fewer than a number is at least 12. So let's define our variable. I'll let n equal my number. Remember, we have this phrase fewer than, which means whatever comes after it actually comes first. 5 fewer than a number means n minus 5. It does not mean 5 minus n. Is at least is greater than or equal to? Well, there we have our inequality. We've written our inequality just like they asked us to. Letter B, the quotient of a number in 3 is no more than 15. Quotient means division. Again, define my variable, n equals my number. So the quotient of a number and 3, so n divided by 3, and that's the algebraic way of writing it. Please don't write it with the division symbol. I mean, that would be the numerical way of showing it. We're in Algebra 2, we can show it algebraically. So n divided by 3 is no more than, when it's no more than, that means it's less than, okay? No more than 15. Could it equal 15? Yes, it potentially could equal 15, so this no more than means less than or equal to 15. It didn't say less than, it said no more than. So no more than means basically at most. All right. To solve an inequality, you're going to do the same types of things that you do with solving equations. The only difference is when you multiply or divide each side of an inequality by a negative number, you must reverse the inequality symbol. Not if you get a negative answer. If you multiply or divide by a negative number, only multiplying, only dividing, and only by a negative number, then you must reverse the inequality symbol. So your properties of inequalities are exactly the same as your properties of equations. Okay, and I'm just going to show you these here. You can look at them a little bit. They're just a good review. You have the transitive property, the addition property, the subtraction property, the multiplication property, the division property. You've done these and used these most of your career in math. You probably just don't know which property they apply to. You just apply them. All right, let's solve and graph some inequalities. Let's solve this first one. Negative 3 parentheses 2x minus 5 plus 1 is greater than or equal to 4. Okay, just like the equations, we have to isolate the variable, which means if we have to distribute first. So I'm going to enter the negative 6x plus 15, make sure you're watching your negative signs, plus 1 is greater than or equal to 4. Now I'm going to simplify. 15 and 1 is 16, so negative 6x plus 16 is greater than or equal to 4. Subtract 16. I'm going to have negative 6x is greater than or equal to negative 12. Divide by negative 6. I am dividing by a negative number, which means I must reverse my inequality symbol. So now instead of greater than, it's less than or equal to. Negative 12 divided by negative 6 is positive 2. To graph this, simple enough, drawing a number line. Right, it's a closed circle at 2, and the line going to the left. This points to the left, it's less than it goes on. Let's look at letter B. Okay. Letter B here says negative 2, parentheses, x plus 9 plus 5 is greater than or equal to 3. Again, distribute. Negative 2x minus 18 plus 5 is greater than or equal to 3. Okay, simplify right here. So negative 2x minus 13 is greater than or equal to 3. Add 13, add 13. Negative 2x is greater than or equal to 16. Divide by negative 2. Since I divided by a negative number, my inequality symbol must switch. So I have x is less than or equal to negative 8. Okay. So I'm going to draw my number line. Let's put 0 over here. 5, 6, 7, 8, 9, 10, 10 over 5. Less than or equal to negative 8. Closed circle, line going to the left. And please make sure your circles go on the graph, not above the graph. They have to go on the graph itself. I tend to graph the lines above it so that you can see them, but my circles are always on the graph. Let's do a word problem. Plumber A charges $75 for a service charge and $40 per hour. Plumber B charges $50 per hour but has no service charge. How many hours must a plumbing job last for plumber A to cost less than plumber B? Okay, so we have two different plans here. We have plan A and plan B. Let's look at, we're going to have different variables that we're going to need to do. Okay? I'm just going to first of all, I have to determine that we're trying to look and solve for how many hours. So that's my variable. I'm going to let H equal number of hours. I have two plans. Plan A. They charge a $75 service charge plus $40 per hour. So there's the equation for that. 75 plus 40H. Plan B. They don't charge a service fee, but they charge $50 per hour. So you can either leave the 0 off of it, just have it as 50H, or you can put the 0 into it. It doesn't matter. Now it says, how many hours must a plumbing job last for plumber A to cost less than plumber B? So plumber A, 75 plus 40H, has got to cost less than plumber B, which is 50H. So there's my inequality. 75 plus 40H is less than 50H. Now let's solve this equation, or this inequality. I'm going to subtract 40H. So I now have 75 is less than 10H, divided by 10. 7.5 is less than H, or H is greater than 7.5, so it's a lot easier to read with the variable coming first. Notice if my variable comes first, it's off the point for the 7.5, so it points for the 7.5. So in order for plumber A to cost less than plumber B, the job has to take more than 7.5 hours. Okay? So how many hours must a plumbing job last? The job must last more than 7.5 hours. So if it's a 5-day plumbing job, plumber A will be cheaper. But if it's a short 1-hour job, plumber B is going to definitely be cheaper than not having to pay a service charge. Let's look at the second question here. 1B music plan has you pay $9 membership fee and $1 per download. The second plan has a $25 membership fee, but only 50 cents a download. How many songs do you have to download to make the second plan cost less than the first plan? Right? So I'm going to let something equal my, I'm going to let B equal my number of downloads. We always define our variable first. Okay? I'm just going to have, there's two plans. First plan. Okay? $9 membership fee plus $1 per download. Second plan. $25 membership fee plus 50 cents a download. Okay? Because how many songs do you have to download to make the second plan cost less than the first? Second plan has got to be less than the first plan. So there's our equation. Alright? 25 plus 0.5b has got to be less than 9 plus b. Okay, I'm going to subtract 0.5b here. 25 is less than 9 plus 0.5b. Subtract 9. 25 minus 9 is 16 is less than 0.5b divided by 5. Okay. So 16 divided by 0.5 is 32. So we have 32 is less than b, or b is greater than 32. So to make the second plan cost less than the first plan, you have to download 32 songs from the per month. It's a lot of downloaded songs. Right? I'm on the internet way too much and not doing enough math. Okay? So you have to download more than 32 songs. Remember, always answer your word problems in a complete sentence. There we go. Okay, let's look at compound inequalities. Actually, let's look at inequalities that may not have a solution. May or may not have a solution. Got ahead of myself a little bit there. Okay. So it says, is the inequality sometimes, always, or never true? Well, let's solve this. 3x plus 9 is greater than or equal to 6x. 6 plus 3x. There, 6 plus 3x. 6 plus 3x. And basically, the x's are going to cancel out there each on different sides of the inequality. So I now have 9 is greater than or equal to 6. 9 is always going to be greater than 6. Since that's a true statement, since this is true, that means this inequality will always be true. No matter what you put in for x, this inequality will always be true. Let's look at the second one here. 9 minus x minus 5. Well, 9 minus 5 is 4. 4 minus x is less than negative x plus 4. If I add x both sides, I get 4 is less than 4. 4 is never less than 4. Right? 4 is equal to 4. 4 is never less than 4, so this is never true. Now, if we got a solution like x is less than 4, then that would be sometimes true, because whenever we put in a number that was less than 4 for x, it would solve the inequality. But if we put in a number that was greater than 4, then it wouldn't solve the inequality. So if it ends up to be a true statement, it's always true. If it ends up to be a false statement, it's never true. And if it ends up to be a solution like x is less than 6 or x is greater than 5, then it's sometimes true. Now we can get into compound inequalities. You can join two inequalities with the word and or the word or to form a compound inequality. We're going to look at both of these. Okay, we're going to look at the and inequalities first. To solve a compound inequality containing and, you have to find all the values of the variable that make both inequalities true simultaneously. Okay, so to solve and graph, a over 2 is less than 3 and negative 3a plus 5 is less than 8. It's an and equation, so they both have to happen simultaneously. So I have a divided by 2 is less than 3, and negative 3a plus 5 is less than 8. To solve this one, I'll multiply both sides by 2, and I get a is less than 6, and subtract 5, and we get negative 3a is less than 3 divided by negative 3 divided by negative, so a is greater than negative 1. So we have a is less than 6 and a is greater than negative 1. You can actually write that as a compound inequality without the word and. Okay? You have to have all your inequalities going in the same direction. A is greater than negative 1. A is greater than negative 1 or less than 6 all at the same time. That's what these two things mean when you write it as 1. It means a is between negative 1 and positive 6 because it's greater than negative 1, but it's less than 6, so it has to be between those two numbers. That's what an and inequality says. Okay, because if I was to graph this, okay, negative 6 is positive 6. If a is less than 6, we would be going, I'll do this one in green, all the numbers that go that way. If a is greater than negative 1, and those in purple, that would be all the numbers going this way. And where do they intersect? Only here. So the solution to this, okay, the solution to this inequality is between negative 1 and positive 6, and only those numbers, not including negative and positive 6. So this is the graph of the compound inequality of an and. The compound and inequality will always go and touch each other. Do not leave it like this. This is wrong because you can't have these extra pieces at the ends. You have to stop it where it's. Okay? I actually prefer the solution like this, but you can write it with the word and. Right, let's look at the second one. 2x is less than 12, and 5 is less than or equal to 3x minus 1. Okay, so 2x is less than 12, and 5 is less than or equal to 3x minus 1. 2x is less than 6. Add 1 here, add 1 here, 6 is less than 3x, divided by 3, divided by 3. 2 is less than or equal to x. So x is greater than or equal to 2, but less than 6, because there's an and in here. And if I were to rewrite this, we'll say a is greater than or equal to 2. Okay. So if I want to rewrite it as a compound inequality without the word and, you can leave the word and in there, but I prefer not to because it's easier to graph if you don't. Okay. Since x is greater than or equal to 2, the smaller number always has to go on the left. 2 here, less than or equal to x is less than 6. X is less than 6 but greater than or equal to 2. And so x is between 2 and 6. So if I was to graph this, why I put 0 there? Silly me. Graph that again a little bit better. 2, 6. X is greater than or equal to 2, but less than 6. Close circle of 2, open circle of 6. The line that goes between the two. So you could write it this way, or you could write it as x is less than 6 and 2 is less than or equal to x, or x is greater than or equal to 2. Doesn't matter. I prefer it written compound because it's easier to graph, but if you prefer to write the other way, then it's fine. Alright, now if we're looking for the OR equations, you're finding all the variables that make at least one of the inequalities true. It doesn't have to make them both true, not single time simultaneously. It's just one or the other. 5 minus 2m is greater than or equal to 21, or 4m minus 1 is greater than or equal to negative 21. You can't combine OR equations. They're ORs. They're always going to be ORs. So if I have 5 minus 2m is greater than or equal to 21, or 4m minus 1 is equal to negative 21. Solved it. Okay, I'm going to subtract 5, so 5. Negative 2m is greater than or equal to 21 minus 5, which is 16. Divide by negative 2. M is greater than or equal to negative. Whoops, I divided by a negative. Must switch my inequality symbol. Almost forgot. M is less than or equal to negative 8. Or over here, 1, 1. or n is greater than or equal to negative 20 by 4. I don't switch my inequality symbol because I'm not dividing by a negative number. I may have a negative answer, but I'm not dividing by a negative number. So I have n is less than or equal to negative 8, or n is greater than or equal to negative 5. So I'm going to graph these. Okay. N is less than or equal to negative 8. That takes negative 8. Line to the left and it's less than. Or n is greater than or equal to negative 5. Okay. Greater than or equal to negative 5, close circle at negative 5, close line going to the right. Or equations will always go opposite, and equations will always point toward each other. And that's the easiest way to solve these. And again, this should be reviewed. You should have done almost all of this in Algebra 1.